According to the cleaninginstitute.org, the average person washes their hands more than 10 times a day, 67% of this being women and 32% being men. As we know, washing our hands requires using a mixture of soap and water, so from this study you can see how much soap is used daily by pretty much everyone. Today, soaps come in many different forms and they have different ingredients depending on what the intended use is. So there's bar soap, which is just solid soap, and when it gets wet, it rubs off. There's facial soap, which is typically a little on the lighter side just because you're putting on such a sensitive area. There is shampoos. These really do differ in ingredients depending on what your use is for. So if you have color treatment, the texture of your hair, stuff like that. Body wash and basic liquid hand soap. According to soaphistory.net, soap was first used in 2800 BC by the Babylonians. They first made soap by combining boiled fats and ashes, but at this time soap really only had the intended purpose of cleaning wool products and being used medically. It was never used to clean skin or anything. In the following years, other civilizations caught on to this. The Romans, Egyptians, and Mesopotamians started making their own soap, and they used the same ingredients as the Babylonians, but included specifically animal fats and salts. Up until 1865, soap was only in the form of a solid bar, but William Shepard, according to botanysoap.com, was patented for making the first liquid soap in the form that we know it today. Liquid soap was really only used industrially until 1970. It was only found in hospitals and bigger locations like that. It wasn't sold in stores or found in households typically. But it started to become mass produced and was found in stores. People purchased it, and it was really significant for the time because it made cleaning non-solid surfaces so much easier than it would have been with just a bar of soap. According to chemistryexplained.com, soaps are surfactants that mix with water and oil-based substances. One end of the surfactant is a charged hydrophilic, meaning that it loves water, and it is soluble as well as ionic. And the tail of the molecule is a neutral hydrophobic, meaning that it does not mix well with and repels water. Depending on the ingredients used in the specific soap, the length of the molecule will vary, but it is typically pretty long. Soap does not work without including it with some sort of water, but water alone has a high surface tension, meaning that the H2O molecules stick together rather than to a surface. So when soap is combined with the water, the molecules are better able to spread on a surface and remove any dirt and oil that might be contaminating it. The term saponification literally means turning into soap. So this term describes a chemical reaction where the oils and fats used for making soap, also known as triglycerides, make a contact with a strong alkali solution, such as sodium hydroxide. The process of saponification releases heat, which means that making soap is an exothermic reaction. The triglyceride ingredients react with the alkali base and result in forming soap and glycerol, which is just a byproduct of soap. This process can take up to 1 to 2 days, but it can be adjusted based on the amount of heat that you use or do not use. This picture demonstrates how the triglyceride fat breaks off into become glycerol and soap, and it shows the different molecules and how they form. So how soap actually works to clean your skin goes back to the hydrophobic and hydrophilic ends that we previously mentioned. The hydrophobic end of the soap molecule attaches to the oil, and the hydrophilic end drops out into the water, which causes a drop of oil to form. And these oil drops are then suspended into the water, and they cause the grease and dirt to be pulled off of your hands, and all of that grime is then suspended into the water and rinsed away off of your skin. Soap itself is very effective in removing bacteria and microbes from any surface that you are cleaning, and according to the University of California, there's really no purpose in using soaps that have antibacterial agents such as trichlocarbon and triclocerin, which are chlorinated antifungals, and the compounds really aren't any more effective than just regular soap itself.